Okay, so far, well, let me just say, ever since you started your online classes, what you've been doing with Dr. Kaba is to, okay, you find revenue, you find total cost, you find profit. And, you know, if you check the aims for this module is to learn to maximize the profit, to maximize, which is maximizing the revenue, and to minimize the cost. And what you've done so far, you were taught how to calculate, how to find the revenue, the total cost, and the profit. And then the next step is to learn to maximize the profit and the total revenue. That's the reason why we are doing differentiation. That's the reason why we need to learn differentiation in this course. Because differentiation will help you minimize the profit. Like using derivatives are helpful in computing the level of outputs and the total revenue in the highest point of profits and the marginal cost, average cost, and the smallest total cost. Okay, that's the reason why we need to learn and understand differentiation. Okay, by the end of this session, I hope you'll be able to explain the concepts of differentiation, apply the power rule, like the differentiation rules. Okay, today I hope I'll be able to cover three rules, which is the power rule, exponential and logarithm, and the chain rule. Okay, we do have other rules for differentiation, but for now, we're only going to stick on these ones. Just flip this. Okay, again, with the help of derivative, we can find the optimum points of economic functions, like if we have any. Please let that one in. Okay. We have the rules of differentiation. As I said, we will cover the power rule, the exponential rule, and the composite and the chain rule, which is the rule that is applied on the differentiation, on the composite function, right? Okay, before we apply the differentiation, the differentiation on finding on maximizing the profits and the revenue and minimizing the total costs, we need to learn the rules of differentiation, because there are different rules that need to be applied in different functions. Like, for example, we'll start from the power rule. Okay. Okay, this is just the basic rule that's determined the derivative of x to the power n, for example, like where n can be any real number. For example, this is the basic differentiation rule that can be applied to a term like this or a function like this. For example, let's say we are given y equals f at x, and this is equal to x to the power n. And we are asked to find the derivative of this function. Okay. And another thing that you need to know, the derivative is denoted by dy over dx, or they can say find f prime at x or x bar. This is the same thing. It's like you need to differentiate the function y of x. Okay, this means you differentiate the function y with respect to x. F prime is also the same thing. We are differentiating the function, the f function with respect to x, and x bar means we are differentiating the given function with respect to x. Okay, that's going back here. Let's say we are given this function y is equal to f at x is equal to x to the power n, and we are asked to differentiate this function, right? I said, if you are given a function like this and you are asked to differentiate it, then you need to apply the power rule, which is the basic, that's the basic rule of differentiation. Okay. If you are given this function and you are asked to find this y prime of x, then your y prime of x would be n times x to the power n minus 1, right? Okay, you'll take the power, you multiply with it, then after that you subtract 1 from the power. That's why we have n times x to the power n minus 1. Okay, for example, let's say we have y equals f at x equals x to the power 10, and we are asked to find this y prime at x, right? We said f prime at x, if we are given a function like this, we first take our exponent, which was n in this case, but our n now is 10, right? So you take 10, you multiply with it, then you then subtract 1 from the exponent. So this means our derivative, our f prime would be 10x to the power 9, right? Okay, let's do another example. Let's say again, you are given y equals f at x equals x to the power 100. Okay. Again, we compare this function to that one. Okay, we said if we are given y is equal to x to the power n, then dy over dx would be, you take n, you multiply with it, and then you subtract 1 from n, right? And our n now, our n is equal to 100, right? So we take this n, you substitute back here. And if we do that, we'll have dy over dx, which is the same thing as f prime at x. Okay, we substitute hundreds where there is n. And if we do that, we'll have hundreds x to the power 100 minus 1. And okay, minus 1. And if you simplify this further, this would be 100 x to the power 99. Okay, and this is our f prime, like our first derivative. Okay, Do we have questions so far?
Yes, madam.
Yes, I'm listening.
I would just like to ask the dy over dx, when would you use that rather than f prime x? Is there any difference between the two?
The difference between these two?
Yes, because I understand that it's the same way of getting the derivative, but why is there two stating it?
It's the same thing. It's the same thing. That's why I have equal here.
All right, no problem. Thank you.
You can write dy over dx is equal to 100 x to the power 99, or you can write f prime of x equals to 100 x to the power 99. There is no need for you to write both of them because it's the same thing. The reason I wrote it is because other people prefer y prime and others prefer dy over dx. So I'm just trying to accommodate everyone.
All right, thank you.
Okay, can we move on? Okay, just a second. Okay, another thing that you need to know about the power rule. If you are given any term and that term is multiplied or divided by any constant, right? Then the term is differentiated and then multiplied by the constant. Okay, for example, if we are given y prime as x to the power n, right? And we are asked to differentiate this function. Okay. Let's say you are given, you are told that k is a constant, meaning k can be any number. It can be 2. Okay, I'll do k equals to 2. K equals to 1 over 2. Can be k equals 3 over 4, right? If you are given a function like this, a term multiplied by a constant, then you are asked to find the derivative of this function, of this term. Okay, your dy over dx, which is the derivative of y with respect to x, meaning we are differentiating the function y with respect to x. Okay, the derivative of this, you'll take n, you multiply n by this. You'll take n and then you'll multiply that n with this constant. So we'll have k times n, again, x to the power n minus 1, we subtract 1. Okay, for example, let's go back to that's our first equation. We had y equals x to the power 10, right? Now, let's say our function is now y equals k x to the power 10. Okay, we'll do k equals half 2 and 3 over 4. Okay, let's say our k is equal to 2. Our k is equal to 2. Our derivative, which is dy over dx, would be 2 times 10 to the power k 10 minus 9. And then you simplify. And if you simplify, we'll have our derivative as 20x to the power 9, right? And if our k is equal to 1/2. Our derivative, which is dy over dx, would be 1/2 times 10 x to the power 10 minus 1. And if you simplify this, you'll have 5x to the power 9. Right? And let's say our k was 3/4. If our k is 3/4, again, we'll have dy over dx equals 3/4 times 10 to the power, or times 10 times x to the power 10 minus 1. And if you simplify this further, you will have, okay, you have 5 here. So this means you'll have 15/2 x to the power 9. You can leave it like this, or you can leave it as 7.5 x to the power 9. It's up to you, because you are writing a multiple choice. If there is this as part of the option, this won't be there. And if there is this one, then this one won't be there. Just choose the one that you see there. Okay. Are we still fine?
Yes. Yes, ma'am, we're fine.
Okay. Another thing, our constant can be positive or negative. But it doesn't matter. The sign of our constant will always follow the same rule. Okay, for example, let's say our k was minus 5, right? Remember, our function was y equals kx to the power 10. So if our k is equal to minus 5, this means our function is minus 5x to the power 10, right? So this means our dy over dx would be equal to minus 5 times 10 x to the power 10 minus 1. And this will give us minus 50 x to the power 9. So it doesn't matter the sign of our constant, will always apply the same rule. Okay. Another thing that you need to know about the derivative. Ne? The derivative of a constant term will always be 0. Like, for example, let's say you are asked to differentiate 10. Let's say you are given your function as y equals 10, and you are asked to find dy over dx. Your dy over dx will always equal to 0. Doesn't matter like how big or small is your constant. The derivative of the constant will always be 0, right? Okay. Remember, we said if we are given y equals kx to the power n, right? Then your dy over dx will equal to kn x to the power n minus 1, right? Okay. Now I want to show you why is the derivative of a constant 0. I'll show you using this rule, right? Y equals K. Okay, again, we're going to be using K as our constant in the here. Okay. Remember, in I think it's grade 8, where you learn the exponents, right? There, from the rules of the exponents, you were told that the derivative, you were told that any number raised to the power 0 is 1. Okay, besides 0, because 0 raised to the power 0 is undefined. But besides 0, any number raised to the power 0 is 1. Like, for example, 10 to the power 0 is equal to 1, right? 120 to the power 0 is 1. 1 to the power 0 is 1. 2 to the power 0 is 1, right? And we know that anything multiplied by 1 will get that thing. Like, if you multiply any number by 1, then you'll get that number. Like, for example, if we have 10 times 1, 10 times 1 is 10, right? If we have 1 times 1, 1 times 1 is 1, 2 times 1 is 1, right? 120 times 1 is 120, right? And let's go back here. We said K is a constant, meaning K can be any number, right? And we said any number multiplied by 1, get that number, right? Okay, so this means we can write this term as Y equals K times 1, right? Okay, I hope we are still together. We can write Y equals K as Y equals K times 1, because K times 1 is the same thing as K, because K is any constant, and any constant times 1, it's any number times 1, it's that number. And K it's any number. So K times 1 is K, right? So this means we can write K as in K times 1, right? Okay, going back to this one, right? We said any number besides 0, any number raised to the power 0 is 1, right? I hope we are still together. Any term raised to the power 0 is 1. So we can write 1 as 10 to the power 0. We can write 1 as 120 to the power 0, right? We can write 1 as 2 to the power 0, right? Okay. We can write 1 as any 10 to the power 0. Okay. I'm going to let this one to be x to the power 0, because x to the power 0 is the same thing as 1, right? So I'll have K times x to the power 0, right? So this means our function is now y to the power k x to the power 0. Okay, the reason I'm writing x to the power 0 times k is because okay, I'm trying to show you that any constant any derivative of any constant is equal to 0. You can apply this rule, the one that we did, the power rule of differentiation, to any constant. You will get 0, right? Okay. Remember, this is the same thing as k. Y equals kx to the power 0 is the same thing as y equals k, right? Okay. Remember, I said if you have y equals kx to the power n, then your dy over dx would be k times n x to the power n minus 1, right? If you compare these two terms, you will see that k is equal to k and x is of n is equal to 0, right? Okay, we have k as k, and we have n is 0. Okay, and this is what we want to find, the derivative of y with respect to x. This is our y, equation y, function y, and we want to find its derivative, which is dy dx. Okay, dy dx. We said k is equal to k, right? So where there is k here, we can write our k. So we have k times our n is 0. So where there is n here, we put 0. So we have k times 0, x to the power n, which is 0, minus 1, right? What is 0 times any number? 0 times any number is 0. Either we say 0 times k, we get 0. Then this 0 times this will give us 0, right? So rather than doing all these steps, if you are asked to differentiate any constant, then you just go straight and be like, the derivative of any constant is 0, right? Okay. Let's say we are asked to differentiate 100, then your dy over dx would be 0. You are asked to differentiate y is equal to minus 1 over 10. The derivative, which is dy over dx, will be 0. So it doesn't matter which constant you are given, your derivative will always be 0. Okay? Before I continue, do we have questions?
No, ma'am, you can continue.
All right, thank you. Another thing that you need to know with derivative, if you are differentiating the sum of two terms, then the derivative would be the sum of those terms. The derivative of that would be the sum of the derivative of those terms. Like, for example, suppose we are given a polynomial y equals ax to the power n plus b x to the power n minus 1 plus any terms up to, okay, that's b x to the power 2 plus d x plus plus e. Suppose we are given a function like this. This is a polynomial. And you are told that a, b, c, d, e, these are the constants. Okay. If you are given a function like this, the derivative of this function, which is dy over dx, would be the derivative of this function plus the derivative of this term, or the derivative of this term plus this term plus this term plus this term. Okay, which means we'll have the derivative of ax to the power n plus the derivative of b x n minus 1 plus the derivative of c x squared with respect to x, right? Plus the derivative of dx plus the derivative of e, right? Okay, this means the derivative of this polynomial will be the derivative of the sum of the terms from that polynomial. Okay, then let me do an example. Suppose our polynomial is given like this. Okay, we have y equals x cubed plus 10x minus 100, right? And we are asked to find dy by dx. Okay, this is a polynomial with 3 terms. So this means the derivative of this polynomial would be this, the sum of the derivative of these 3 terms, meaning our dy dx would be dx of x to the power 3 plus dx of 10x plus dx of minus 100, right? Okay. Then we differentiate this term, we add the derivative of this term, then the derivative of this term. We have x to the power 3. We said if we are given a term like this, the derivative of this term, we take the exponent, we multiply with it. So this means we'll have 3x to the power 3 minus 1, right? And okay, plus the derivative of this term. The derivative of this term, we have our n equals 1, right? So this means we have 10 times 1. Okay, 10 times 1, x to the power, our n is 1. So we have 1 minus 1, right? Plus the derivative of this term. This is minus 100, and minus 100 it's a constant, right? It's any number. It's a constant, and we said the derivative of the constant is 0, right? So this means we'll have 0 here. Okay, and then we simplify. We have 3x squared, and 10 times 1 is 10. So 10x to the power 0, because we have 1 minus 1. Okay, there is no need for us to add 0. Okay, we still need to simplify further. Remember, any number or any term raised to the power 0 besides 0 is 1, right? So this means we can write this as 3x squared plus 10 times 1. Okay, and again, this is 3x squared plus 10. And this is your dy dx. You can't simplify further from here. You can just leave it like this. This is your final answer. So if we are asked to differentiate a polynomial like this would be your answer. You'll have 3x squared plus 10. Do we have any questions? Yes, no?
Or you can continue.
Well, thank you. Okay, let's do another example. Let's say now we are given a function f at x, which is y equals 1 over x cubed. And we are asked to differentiate this. Okay, this is still a polynomial. Remember, a polynomial is a function like this, y equals a x n plus b x to the power n minus 1 plus c x to the power n minus 2, so on and so on. Okay, this is the exponential, which is the polynomial, right? Okay. We said if we have something like this and we are asked to differentiate, we need to apply the exponential rule, which is the only rule that I've been teaching so far, right? Okay. If you are given a function like this, 1 over x to the power 3, you need to apply the exponents, the rules of exponents again, the one that you were told in grade 8. Okay, that says 1 over x to the power n is the same thing as x to the power minus n, right? Our n in this case is 3, meaning we can write this function as y equals x to the power minus 3, right? And if we, okay, since we now have our function like this, we can then apply the power rule here. Okay. Our n is minus 3. And the power rule says if you have y equals x to the power n, then y prime, which is dy over dx, would be n x to the power n minus 1. Our n is minus 3. So this means our dy over dx would be minus 3x to the power minus 3 minus 1, right? Okay. You need to simplify further here. Okay, and if you do that, you'll have minus 3x to the power minus 3 minus 1. This would give you minus 4, right? Okay, we don't leave a term with a negative exponent. We, like, always just try and leave your term, your answer with all the terms with positive exponents. You see, right now, our exponent is negative, which is minus 4. Okay? Going back. Sorry about that noise, the background noise. Okay, we said if we have 1 over x to the power n, it's the same thing as x to the power minus n, right? Meaning if we have x to the power minus n, you can write x to the power minus n as 1 over x to the power n, right? Okay, we have 3 to the power minus 4, right? We said x to the power minus n is the same thing as 1 over x to the power n, meaning we can write this term as minus 3 over x to the power 4. And this would be your final answer. You can leave your answer like this because our term has a positive exponent now. Okay, if because you're writing the multiple choice, the answer is left like this, it's still okay, but if this it's not there, try and use and apply the rules of exponent to leave your term like this, because it's always right to leave all your terms with positive exponents. Even if you were given your terms with negative exponent, try and leave them with positive exponent. Okay. Let's do this. Yeah. Okay. Do we have questions so far? Yes, no. Okay. Yes.
Oh, yes, Mr. Waz. If I were to leave my answer as just the one you just wrote, if I had to leave it as 1/3 over, it's 1 over 3 here. If I were to leave the answer here as a 1/3 of x to the power 4, as x as the denominator, x to the power 4 is the denominator, would that be wrong?
Like, as in if you leave your answer like this?
No. And then if I simplify further from that, I see you put the 3 as the numerator. Would I be wrong as putting the 3 as the denominator?
If you decide to put your 3 as the denominator.
That. Could you try again?
Pardon? If our 3 was 3 to the power minus 1, then okay, let's say we have 3 to the power minus 1. You know this is the same thing as 1 over 3, right? So if this answer was 3 minus 1, x to the power minus 4, then you're supposed to leave this answer as 1 over 3 x to the power 4. If this was the case.
Okay, no, I understand. Okay.
All right. Any question? Okay. Let's try and do this one. Okay, I'm gonna give you a few minutes to find f prime, which is dy over dx. Let's try and work on this one. Yeah, I'm giving you 5 minutes. This 5 minutes is too much, but you can have 5 minutes to work on this one. After 5 minutes, we'll work on it together. But please try and attempt this one and solve that one. Guys, are you winning?
Yes, ma'am.
What did you all get as your prime x?
1.
I'm listening.
I thought 1 plus 20x over 3 cubed.
Yes.
Minus 24 over x to the power 4
Yeah.
and minus 20 over x to the power 5.
Oh, plus 20.
Is it plus?
No, it's minus.
Anyone with a different answer?
Sorry. That's fine.
Yeah, it's fine.
I got 1. I started with 1 over x.
1 over x.
Yeah. And then the rest is the same.
Okay, here we have 1 over x,
Yes.
meaning if you differentiate said x, you obtained 1 over x.
Is 1 over x is the same as 1.
1 over x.
Yes. Is that not the same as 1, ma'am?
No, it's not the same.
Okay, so I should have left it as 1.
Yes. Okay.
Okay.
I'll do just that term. Say we are given f at x as in x, right?
Yes.
This means okay, if your f at x was x to the power n, then your f prime was going to be n x to the power n minus 1, right? If you compare these two, x to the power 1 and x to the power n, this means your n is equal to 1, right? If your n is equal to 1, you go to this function, to this derivative, you substitute 1 where there is n. This means you'll have f prime at x is, okay, we have n is equal to 1. So we have 1 times x to the power, our n is 1 minus 1. So this is the same thing as x to the power 0, right? And we said any term or any number raised to the power 0 besides 0 is 1. Do you see where you made a mistake?
Yes, ma'am. I see. Pick because I have two different answers. I have the one with just 1 and then the one with 1 over x. But I see where I went
It's
wrong.
just 1.
Okay.
All right, thank you. Do you have any questions? Okay, in your own time, spare time, please work on these two. Y is equal to 2 square root of x over x, and y is equal to x cubed plus 1 over x cubed plus 6 over x squared, right? Okay, please do work on this to use that time. Okay. A hint here. We will use the rules of exponent, which is okay. If you have nth, and okay, we have nth roots of x to the power m. You can write this as an x to the power m over n, right? So this means if our n was 2, or let me say our n is 3, say we have something like this to the power 2. You can write this term as in x to the power 2 over 3. Okay, if there is nothing here, like just a square root of just a square root. Square root is the same thing as x to the power 1 over 2, because this means this is the square root of x to the power 1, meaning our m is 1. And you know that a square root can be cancelled off by raising that term to the power 1/2. So this is your hint. Please do work on these two on your spare time. Okay, we still have 30 minutes. We can do another rule. Which is the exponential and the natural logarithm. Okay, which is the rule that is applied when we are differentiating an exponential and a natural logarithm function. Let's say you are given an exponential function like y equals e to the power x. E to the power x. And we are asked to differentiate, to find the derivative of this function. Okay. You know, you can apply the power rule if you are given, only if you are given a function like this. F of x equals kx to the power n. Then if you are given a function like this, you can apply the power rule. Here we are given an exponential and an exponential function, the logarithm function, right? Which is e to the power x. If we are given something like this and we are asked to differentiate a function like this, the derivative of this function is this function itself, meaning dy over dx would be e to the power x, right? So say you are given a function m equals e to the power n, and you're asked to find dm over dn over dn. Your dm over dm, which is the derivative of this function, would be the function itself, right? But when the exponential function has a constant, then the derivative of that function would be the exponent times that function itself. Okay? Meaning, suppose if you are given this function as in y equals e k kx, right? So if you are given an exponential function that has a constant, then the derivative of that exponential function would be the constant times that function itself. Meaning the derivative of this function, okay, k is the constant in this case. Meaning the derivative of this function would be dy over dx is equal to k e to the power kx, because it's the constant times that function itself. Okay, if this function was y equals e to the power 10x, then the derivative of this function would be dy over dx equals 10 e to the power 10x, right? Again, if we were given a function like this function is y equals e to the power 1 over 10x, then the derivative of this function, which is dy over dx, would be 1 over 10 e to the power 1 over 10x. If there is no constant, then the derivative of that function is that function itself. If there is a constant, then the derivative of that function would be the constant times that function itself, right? Okay. Then another thing, this is just, let me just leave it like this. Let's move on to the derivative of the logarithm function, which is log of base e. Like example, say we are given a function, the logarithm function, which is natural logarithm as y equals ln x, right? The derivative of this function would be 1 over x, right? So we have dy over dx would be 1 over x, right? If we're given this function as in m equals ln q, then dm over dq was going to be 1 over q, right? Okay. That's the exponential. Those are the rules of differentiation for an exponential and the natural logarithm function. Okay, let's move on to another rule. Okay, before we move on, do we have questions? Yes, no?
No
Okay,
questions.
Still have 20 minutes. Let's move on to another rule, which is the chain rule. Okay. Question would be, where do we apply this rule? Okay. You can only apply this rule in a composite function, right? Sometimes the composite function is called a function of a function, right? Or an inner and outer function, right? For example, if you are given a function, two function, one function is inside function 2. For example, if we are given something like this, y equals 3x plus 4 to the power 10, right? You see, here we have a function inside the bracket and the function outside the bracket, right? Meaning we have an inner function and the outer function. If you have a function like this is called the composite function. right? Or a function of a function. Okay. So if you are given a function like this, you are asked to find the derivative of this function, which is dy over dx, meaning we are differentiating this function with respect to x. Okay. Here, to differentiate this function, you need to apply a chain rule, right? A chain rule says if we are given an inner function and the outer function, then the derivative of that function would be the derivative of the inner function times the derivative of the outer function, right? For example, okay, we have this function, 3x plus 4 to the power 10, okay? I will say the inner function, I'll let the inner function to be u, okay? Inner function is u, and u is equal to this inside part, which is 3x plus 4, right? If u is the inner function, I'm gonna let the outer function to be v, right? Okay. Outer function to be v. But the outer function is u to the power 10, right? Okay. Meaning we have v is equal to u to the power 10. Okay. This means we have y equals v of u. V of u is u to the power 10. Okay. If we have a function like this, an inner function and the outer function, the derivative of this function would be, okay, dy over dx would be the derivative of the outer function, which is d over d. Okay, I will call it v prime, because you know f, the derivative of f is f prime. You can write the derivative of y, which is dy over dx, as in y prime. So again, you can write the derivative of v as in v prime. Okay. If we apply a chain rule in a function like this, the chain rule will say the derivative of this function would be the derivative of the outer function times the derivative of the inner function. Right? Okay. We have our inner function u as u equals 3x plus 4, right? And the outer function is v equals u to the power 10, right? But the derivative of this is the derivative of this times the derivative of this, right? If we are given u as in 3x plus 1, the derivative of this, we need to apply the power rule here to find the derivative of this, meaning we need u prime. U prime, if you apply a power rule here, will give us 3, right? Because we have 3x, right? Y equals 3x, meaning your n, meaning you have y equals k x to the power n. And if we have a function like this, your y prime would be k n x to the power n minus 1. In this case, we have our k as 3 and we have our n as 1, right? Okay, we'll take our k as 3 and our n is 1, and we substitute back here. If we do that, we'll have 3 we'll have 3 times 1, x to the power, our n is 1. So x to the power 1 minus 1, right? And we have 1. We said the derivative of a constant is 0, right? So we have plus 0. And this, we have, this is 1 minus 1. 1 minus 1 is 0. So this means we have 3 times x to the power 0. X to the power 0 is the same thing as 3, right? So this means our u prime is equal to 3, right? Okay, we have another function which is v is equal to u to the power 10, right? Okay, we need to find its derivative. Okay, we have u is equal to u to the power 10. This is the same thing as in if you are given y is equal to k u to the power n. If you are given a function like this, then your y prime would be k n x of u to the power n minus 1, right? You have u, you have k as 1, and we have n equals 10. If we take these and substitute back here, we'll have your v prime as in 10 u to the power 9, right? And we said dy over dx would be u prime times v prime, right? Okay, you can say v prime or times u prime or u prime times v prime. It doesn't matter in this case. Okay, then we take these two, we substitute back them here. We said our u prime is 3, right? Times, we said our v prime is 10 u to the power 9. So we have 3 times 10 u to the power 9, right? This is dy over dx. But our function, we were not given this function as in terms of u. This function was given in terms of x. So your final answer must be in terms of x again. Remember, we said our u is equal to 3x plus 1, right? Okay, we have u. So where there is u, you can substitute u with 3x plus 1, okay? So this means we can write this as in 3 times 10 into, okay, we said u is equal to 3x. Okay, it was 3x plus 4 to the power 9, but it's okay because the derivative of 1 is 0 and the derivative of 4 is 0. It's okay. So it won't make any difference. So this means we have 3 times 10 to the power 3x plus 4 to the power 9. Then the next step is to simplify this. If you simplify this, you'll have 30 into 3x plus 4 to the power 9. And you can leave your answer like this. So if you are given a function like this, you are asked to find its derivative. This should be your answer. This should be your answer. 30 times 3x plus 4 to the power 9. Okay, this was the chain rule.
All right,
Okay.
hello?
Yes, yes.
Sorry, the v function, one that was v equal to, I think, u to the power of 10 on the next page.
Yeah.
Is that not the basic exponential form of function?
It is. It is.
All right, so does it not then, sorry, is the derivative not then that function itself?
No. Okay, this is the basic like power. It's a power function. An exponential or logarithm. Okay, it would be x to the power something. It's e to the power something. Or I thought you meant the basic power function. If
Okay.
this
No.
was the case here, then the function would have been itself. But
Oh.
we have a power function, right? Meaning we apply the first rule that we did here, which is the power rule.
Okay, thank you so much. I see why I got confused.
Okay, thank you. Do you have questions? Okay. If we don't have questions, let's move on. Here, the chain rule, I will apply the chain rule in 3 functions that we did. The first function was the power rule, right? Which was a function like this. Power function, a polynomial, which was a function like this. F at x equals a x to the power n, right? And then here on the power rule, where there was x, we had a function. Where there is x, we had a function. So it means we have something like this. Our f at x was a into let's say 2x plus 5 to the power n. You see? If you have a function like this, you need to apply a chain rule. But that chain rule will need you to add the power rule. Because you see, this function is in this form. It's just that here where there is x, we are given a function, right? If we have a function like this, again, f at x is equal to a n. We said if we were given something like this, the derivative of this function would be a to the power an. Okay, x. And if we have something like this, f at x is equal to ex, then the derivative of this would be, sorry, I need to put the chart. Okay. If we have a function like this, it's easy to differentiate this because you just take this constant, you multiply with it. And if you have a function like this, e to the power x, you just, okay, the derivative of this function would be the function itself. Now, suppose here, again, where there is x, we have a function, right? Meaning we have something like this, f at x, okay? Initially, we have e to the power ax, and we said f prime here would be e to the power ax. Now, suppose where there is x, we are given a function again, like here. Remember, again here, the initial function is ax to the power n. We said here it's easy, we apply the power rule. Now, where there was x, there is a function. If instead of x, we have a function, then we use a chain rule, because this means we have an inner function and the outer function. Again, let's go back here. Initially, the initial function is e to the power ax. Now again, suppose where there is x, you have a function, another function, meaning, let's say, for example, this function is given as f at x equals e to the power maybe 30 x squared plus 10x minus 2. You see, this function, it's in this form, but here where there is x, we are given another function instead of x. Again, if you have something like this, you need to apply a chain rule. A chain rule would be the derivative of this function times the derivative of the original function. Remember, the original function is e to the power x, right? Now, instead of e to the power x, we have e to the power this function. So the function that is in terms of x will always be the inner function. Like here, instead of x, we had 2x plus 5, right? So we said our inner function is 2x plus 5 because that function is in terms of this x. Again, here, your inner function would be that function that is in terms of x when you return the given function to the original function, right? So this means our inner function, which is, okay, inner, which is u will be 30x squared minus 10x minus 2. Okay, it's plus 10x minus 2. Okay, if this is your inner function, then the outer function would be v would be e to the power u, e to the power u. Okay, I said if you are applying chain rule here on this in a term like this, that chain rule will require you to use the power rule, because if you differentiate a function like this, you need to apply the power rule, right? And if you are given a function like this, you apply chain rule here. A chain rule that you'll apply here will require you to use the exponential rule, because if you are given a function like this, you need to use the exponential rule again, okay? Again, we said the chain rule is the derivative of the outer function times the derivative of the inner function, meaning your dy over dx would be v prime times u prime, right? We can find our v prime and u prime from this because we have u, we have v. You see, your u is a polynomial. If you are given a polynomial, you are asked to differentiate it, you apply the power rule. And we have your v, x, the exponential. If we are given an exponential, you use the exponential rule to differentiate it. Okay. You see, if you look at this function, the u prime would be 60x plus 10, right? And if you look at this function is e to the power, it's e to the power v, it's e to the power u. And we know that e to the power x, the derivative of e to the power x is e to the power x itself, meaning v here, v prime would be e to the power u, right? And then we take these two, we substitute them back here. And if we do that, we'll have, we said v prime is this e to the power u times u prime is this it's 60x plus 10. You see, this function has u. We were not given our function as in terms of u. We need to return, substitute u, the original u back to, so that we'll have the final answer. Okay, we said u is equal to 30x e to the power, right? So this means our final answer would be e to the power, it's 30x squared plus 10x minus 2, right? Times 60x plus 10. Answer like this. You see, it's the derivative of this function times the derivative of this function. Okay. Like another example, suppose you are given your f at x as in e to the power 3x squared. See, the original function here was e to the power x, right? Meaning you can let this function to be the inner function so that it would be in this form. Okay, we said the inner function is u is 3x squared, and v is e to the power u, right? The derivative of this, which is u prime, it is 6x, and the derivative of this is just that function, that term itself, e to the power u. So this means the derivative of the original function, which is f prime, it would be v prime times u prime. It would be 6x e to the power 3x squared. Do we have questions? Okay. I said another dead function was y is equal to ln x, right? Again, if you have a function like this, the derivative of this function would be y prime is equal to 1 over x, right? Now, suppose in terms of x, we have another function, as in y equals ln of x squared plus 3. You need to write this function to be like this, right? When you choose your inner and outer function, your inner function would be anything that is replaced by this x, and then your outer function must be in this form. Okay, so this means your u in this case would be x squared plus 3, and your v would be ln u, right? So if your u is this, then your u prime would be 2x, and your v prime, remember, ln x, the derivative of ln x is 1 over x. So this means your v prime would be 1 over u, right? Remember, the derivative of the composite function, which is the inner function, and the outer function would be the derivative of the inner times the derivative of the outer. So this means our dy over dx, which is v prime times u prime, would be 1 over u times 2x. But we know that our u is x squared plus 3. So this means we have 2x times 1 over x squared plus 3. Okay, you can write this as in 2x over x squared plus 3. Right? Okay. This the composite function simply means the same. Suppose you are given a function y is equal to f of u, right? You take this un as the inner function and this as the outer function. Right? Okay. If you are given a composite function like this, or as in f is g of x, okay? Say you are given something like this or something like this. This means your dy over dx would be dy over du times du over dx, right? So if you have something like this, you apply chain rule here, you should have something like this. Again, if you have something like this, you should have f prime at x is equal to f prime of u times g prime of x. Okay. Here I was just summarizing the chain rule. I was just saying the same thing that I was applying the, which is the derivative of the inner function times the derivative of the outer function. Are we all together?
Yes, thank you.
Okay. Do we have questions? If we don't, in your spare time, please find the derivative of this function. Y equals 10 3x plus 4 to the power 9. Y equals 5 ln 3x 4, and y equals 5e to the power 3x plus 4. Please try and work on this and your spare time. I'll try and start here on our next section. Okay, again, yeah. Before I stop recording, do we have questions? Yes, no.
Ma'am, I would just like to ask, so those questions, are you going to give the answers in the next section?
Yeah, I will try and start here. Please do remind me. Okay. I will only teach, I think I will be able to cover the application too. So I'll only teach differentiation and its application. Then we'll have there is another lecturer joining us who will take over from me. Prof. Mabemadi will start on the 1st of September. So I only have this remaining of August with you. Yeah. Okay, do we have questions? Yes, no. Okay, guys, our class was supposed to end at 17:30, and after 10 minutes of your time, I'm sorry about that. Yeah. Thank you for taking your time to attend.
Ms. Ngoma,
Yes.
you were presenting homework, and now I was writing down. Can I ask you to represent it up again so that I can write it down quickly?
All right.
Thank you.
Okay, I will download this recording and post it on our Moodle channel. Then I will send you guys the link on, I'll upload the link. And is this lesson 2? Yeah, I think it's lesson 2 if it's not lesson 3. You'll find the link to the recording there on under the lessons on Moodle. I think Moodle has a problem today, so I'll try tomorrow to upload this recording.
Sorry, ma'am, can I ask a question?
Yes.
Regarding assignment 2, I've seen that it's been postponed till the 31st of August, if I'm not mistaken.
Yes.
For those who submitted before it was postponed, are they going to be given a chance to resubmit?
You've submitted already,
But I'm not happy.
but I didn't give you guys just one attempt.
Yes.
When is the 31st?
Next week, Thursday, I think.
Okay. On our next section, Monday, please do remind me to give you all one more attempt.
Thank you.
Guys, if we don't have any more questions, I think we should end here.
Thank you so much, ma'am, for
Okay,
thank you, ma'am.
Thank you.